Hey everyone, how's it going? We're here with episode 7 of the FNaF Clickteam tutorial series. So this episode is going to be one of the most intensive because we're diving into animatronic AIs today. I won't waste much more time, we're just going to get right into this. My primary goal with this episode in particular is to show you guys a few really cool techniques that you can use when working with animatronic AIs. I'll try to explain these as best as I can, but since they are more complicated, it may not be the clearest on how exactly these work. I will try my best to go into detail though. So the first thing that we need to do is make an object for our animatronic. For this specific object, I'm making this an object for the character in the cameras. So when it comes to designing your assets in the cameras, the best way of doing that is separating the character renders from the room renders. So what this means is have an object with all of the rooms being empty, and then have your animatronic object where the renders inside of those rooms are separate. If you need a more visual understanding of how this looks, here is Bonnie in the dining area in FNaF 1. In the original game files, Bonnie was essentially merged with the room that he's in. However, in these renders of Bonnie that I'm going to be using for this video, he's separated from the room itself. Even though this is a very bare bones job of doing that, it's just to show how the character renders should be separated from the rooms. Now, once you have your character renders set up for the cameras, we're going to go ahead and import them into our new object that we just made. How we're going to set these frames up is going to be the same as the cam buttons. We're going to align the frames with the order that the rooms are set up as. So for example, Bonnie's dining area render is going to be the second frame of this animation, and Bonnie's West Hall corner frame is going to be the fifth frame of this animation. And as always, make sure to set the animation speed to 0. One other thing as well that you should incorporate as we're importing these frames, if you're importing these frames like I am, where the renders have a lot of empty space where there's nothing there, then what you should do is on that frame, click on this option to the left here titled crop. What this does is it takes out any of the empty space in these frames. This is really helpful because this will help you with saving storage, and with FNaF Fangames, while you don't normally run into any storage issues, if you're making a game that is very big, then this is going to be a very good practice to get used to. What's also good about this is that it also saves the image's hotspot to what it was before cropping the image. So granted that your frames all have the same hotspot, they should all still be aligned after doing this. Now, once all that is done, we can exit out of the object editor. We're also just going to make sure that our Bonnie object is invisible at the start, since we only want him to appear when we're looking at him. Now, in this object, we'll want to make an alterable value titled movement. This will effectively be responsible for keeping track of Bonnie's movement timer. Also, while we're at it, I'm just going to real quick set up the actual AI values for the animatronics. If you've watched episode 3 of this series, it's going to be a similar process to our night value setup. All we need to do is navigate to our game's global objects, which is done by clicking on the app and going to values. From here, we're going to make a global value. I made 4 right here, but obviously you can make as many as you want depending on how many characters you have in your game. And we're going to set this Bonnie AI global value to 20. With that done, we're going to skedaddle to the event editor and make a new group called Bonnie. So in this group, we're going to first set up the movement for Bonnie. To do this, we're going to first make sure that his movement timer is set up as soon as the night begins. So we'll make a condition checking for if Bonnie's AI value is greater than 0, and then create another condition that makes the event run once in the frame. From here, we're going to make a new action that sets Bonnie's movement alterable value to a certain value. Now, what this value is going to depend on Bonnie's AI value. Now, there's a couple ways of setting this up. The most efficient way for people who are beginning is to have what I call a base value, and this value is going to be subtracted by Bonnie's AI value, and that AI value is going to be multiplied by a certain number, which I'll call the amplifier. Because we're going to continuously subtract this value, and because the game will subtract 60 from this value every second, since the game runs at 60 FPS, we'll need to calculate what our base value should be and also calculate what Bonnie's movement timer would be at 20 AI. So at around AI level 1, for example, let's say we want Bonnie to move every 22 seconds in the cameras. So we would calculate 22 times 60, which is 1320, so that would be our base value. Then for Bonnie's movement on 20 AI, we would want him to move every 4.5 seconds. So how we'd calculate the amplifier is more of a process, but just follow along. So we'd multiply 4.5 by 60 to get 270. After that, we'd subtract our base value of 1320 by the value we just got, 270, which gives us 1050. Now with this value, we need to divide this by 20, which is the animatronic's max AI level, which comes up as 52.5. So 52.5 then would be our amplifier value. I will leave a visual explanation on screen so that it's easier for you guys to understand, but this is the best way to get these values. And of course, these values can be whatever you want, they can be different. These are just the ones that I picked for this example. Now we're going to actually begin subtracting our movement value here, which is done by making a new line, which also checks if Bonnie's AI is greater than 0. After this, we're just going to make an action subtracting the movement value by 1. From here, we're going to make a new line which checks for if Bonnie's movement timer has depleted entirely. So once again, we'll make a new line which checks for if Bonnie's AI is greater than 0, and then make a new condition which checks if Bonnie's movement timer is less than or equal to 0. Then lastly, we'll just add in an only one action when event loops condition. So for the action in this line, this is when Bonnie would move from one room to another. Now there's two ways that we can do this. One, we have several lines here that make Bonnie move to different rooms depending on which room in the cameras he's currently in. However, there's a second way to do this, which I'm going to show you all right now, and it involves utilizing something called the string parser. So if we go back into our frame editor, we'll add in the string parser object. If it's not available in your object list, then it is available through the extension manager, so you should have no problem getting it through there. Now when you paste the object in the frame editor, you'll be met with this screen here. Normally I just leave all of these on their default settings, but just so you can see, there is an option to attach a string to this object, which I'll explain what this does in a second. You can also toggle on case insensitive, which sees lowercase and capital letters as the same, while case sensitive determines them as different. For this example, it doesn't matter which setting this is on, but just so you're aware, you can change that setting on the screen. You can also change these in runtime as well if you need to change that setting mid-game for whatever reason. For now, though, we'll just leave it all as is. So once our string parser is set up, we'll need to go back to our Bonnie object, and we're going to make something called an alterable string. Now this is found in the same place as alterable values, and they're pretty much just alterable values but in string form. Now what this is essentially is Bonnie's room path. So this determines which rooms Bonnie is going to be moving through in the map. If you know how FNaF 1 AI works, you know that Bonnie and Chica's movements in the cams are randomized. I would not recommend doing that at all, since randomization with character movements, especially without any real cap to it, is a very bad practice, since the characters are never guaranteed to progress to your office. I'd recommend having paths like these, where the characters have a defined path or paths that they go through every time. So how do we set this up? And most importantly, how does the string parser even tie into any of this? Well, essentially, what the string parser does is it splits up strings and has multiple elements stored into it. So it takes one string and it stores several other strings inside of it. How it splits these strings up is it uses something called a delimiter. So when the string parser reads a string, anytime it detects one of these delimiters, it splits up the first part of the string before it and the part of the string after that delimiter key has been read. A delimiter key is usually a special kind of symbol that isn't used often, so a backslash or a bar key, and it does this every time it detects that delimiter key in the string. So here's what it looks like. We have Bonnie's first position on the show stage here, which which is 0. And for simplicity's sake, we're going to have our delimiter key as the right arrow key, so it's easier to see what's going on. Then Bonnie's second position, the dining area, is 1. Then we set up another right arrow key, and then he moves to the backstage, which in my game is identified as 8. So when the string parser reads the string and splits it, it will store all 3 of these values as separate elements, and we can use these to let Bonnie move across the different rooms. Now, I know this looks very complicated, and it kind of is, but I still want to show you guys how this all works. So the rest of the string will just be the rest of Bonnie's path. Obviously, for your game, you would set it up with whatever values you would want your character to go through. The final number of this path is going to be your office, and you want this to be a value different than any of your room values. So for me, I'll have the value for when Bonnie gets to the office as 100. So once we set up that alterable string, we're also going to make another alterable value in Bonnie's object called progress. So the purpose of this value is each time Bonnie moves to a new room, this value will go up by 1, and this will actually be used to determine which room Bonnie will move to in his path once he is queued to move on to another room. And we're actually going to set this progress value to 1 by default, since string parser elements are 1 indexed, unlike a lot of other things we've worked with, which are 0 indexed. With all this setup done, we can finally move back into our event editor. Now the first thing that we're going to do is go up to our miscellaneous group. Here we're going to set up the delimiter for our string parser. So when we make a new action, we'll navigate to the string parser, hover over list tokenizing, delimiters, and add delimiter. From here, we're just going to set up the delimiter key. So for me, that'll be the right arrow key. Perfect. With that out of the way, we can keep adding on to our Bonnie group here. So on this line, which right now doesn't have any actions, we're going to make a new action, and we're going to click on the string parser and go to this option called set source string. So this is just asking for the string parser to read a string of our choice. So when we get to the edit box here, we'll select the room path alterable string from our Bonnie object. After that's done, we're going to add another action, and this one will add the progress value on Bonnie by 1. Next, we'll add an action that changes Bonnie's animation frame. Now this will depend on which room Bonnie has been moved to, which we can only get from the string parser. So in the text editor, we're going to click on the string parser, navigate to list tokenizing, and from here we have a lot of different options. For now, we're going to click on this option just titled Get Element. Now this is getting one of the elements that the string parser has split up. Now when we select this, it's going to ask us for a value, and this value is asking which element we'll want. So with this parameter highlighted, we'll select Bonnie's progress value. So essentially what this does is whenever Bonnie moves from the show stage to the dining area, for example, it sets his frame to the same value as the room that he just moved to. So since the dining area's room value is 1, that means Bonnie's frame value will also be 1. Now you'll notice, but whenever I try to click OK here, it doesn't let me. The reason for that is because the element is actually in string form, and the text editor is asking for a number. So to turn this string into a number, we just need to type in val, and then enclose the rest of this function in parentheses. And now it's saying our expression is valid, and we can apply the change. So now we have the basis for Bonnie moving set up. We just need to make him appear and disappear off the cameras as we're looking at him. Thankfully, this step is fairly simple. All we'll do is add in a condition checking for if the current frame of Bonnie matches with the animation frame of our camRooms object. Then we're going to check for if Bonnie is still invisible, and if he is, then we'll add an action that makes him reappear. Now we can just copy and paste this line and negate all these events and actions where and now checks if we're looking away from the room Bonnie is in, checking if he is visible, and then making him disappear. So after we do all of that, if we go ahead and run our game, we can now see that Bonnie is moving and appearing properly. Now the only issue right now is that his movement timer isn't resetting right now, since it just keeps subtracting itself into negative numbers. Thankfully, we can easily fix that by copying this action that sets Bonnie's movement timer in line 43 and pasting it in the line where Bonnie moves to another room, being line 45 for me. So now, as you can see, Bonnie is moving across the building normally. So already we're in a pretty good spot. Naturally, the next step is to begin setting up Bonnie's code for when he is at the door. The first thing we should do is go into our office object and put in Bonnie's render at the door. Once we get that imported, preferably after the render with the right light, we're going to proceed back into our Bonnie object and create a new flag titled Bonnie at door, which don't think I need to explain what this does. Now in our event editor, we're going to make a new line checking for if Bonnie's progress is equivalent to him reaching the door. So for me, this would be at progress equals 8. We'll also just drag in only one action when event loops condition in here too. Then in our actions, we're going to enable that Bonnie at door flag. So ultimately, this flag will be used to determine when to make Bonnie appear visually at the doorway. So what we'll end up doing is we'll navigate back to our doors group and change any instance where the left light appears to include Bonnie if his flag is on. To do this, we're just going to edit the action of any time the left light appears and add in the parameter of the Bonnie at door flag. However, if you recall, because I placed Bonnie's door render after the right light render, that means Bonnie's render is at index 3 of the office object, meaning if I left this as is, it would cause the right light render to appear whenever Bonnie is at the door instead of, well, his own render. So we're going to put this around parentheses and multiply it by 2 so that Bonnie's render properly appears whenever he's there. Now in this action, whenever it checks for when we click on the left light button, we're going to multiply this Bonnie at door expression that we added in instead of adding it in, so that way even if Bonnie is at the door when the lights turn off, the hallway goes dark no matter what due to the light status flag being off. However, because it's being multiplied, that means if it's being turned on and Bonnie is there, it would show animation frame 2, not animation frame 3. So we need to change this 2 next to Bonnie at door to 3, so that way Bonnie's render appears properly whenever the light is toggled on. There's just one last thing for us to change in this doors group, and then we'll move on to the rest of Bonnie's programming. So here in this line that checks for whenever the left light is on or equal to animation frame 1, we need to edit this condition to include if the Bonnie at door flag is on, and then multiply that by 2, similar to how we did in the first action that we added onto in this group. If we didn't edit this, then whenever Bonnie is at the left door, the lights won't really flicker properly. So as you can see, now when Bonnie has reached the office, he will appear at the door. Neat. So from here, we're going to get out of this doors group and go into Bonnie's group again. From here, we're going to check for conditions for when Bonnie has moved from the door. So for me, that would be when his progress value is equal to 9. We're going to drag this condition checking for his progress value being equal to 8 and change that 8 to a 9. Now from here, we're going to add a condition checking for if the door status flag on our left door buttons object is off, meaning that we failed to close the door on Bonnie. Then after we drag in an only one action when event loops condition, we're going to make a few actions here. First off, we'll set the Bonnie at door flag to off since Bonnie is no longer at the door. I'm also going to make a new flag inside of Bonnie's object called Bonnie in Office. Now in our list editor, we're going to set that new flag to on. Additionally, now in line 44, which subtracts Bonnie's movement timer, we're going to add in a new condition in here, which checks for if that Bonnie in Office flag is off. So once Bonnie has reached the office, his normal movement will stop completely. Now moving back to line 49 here, we'll need to add in some actions related to the left door itself. First, we'll need to deactivate the light status flag. Since Bonnie's in the office, we'll no longer be able to use the left door buttons, so this will disable the lights in case they're on when Bonnie moves. Next, we'll go up to our doors group again. I know, I said we were done here, but this is going to be an important thing to add. In the two lines within this group that check if we've clicked either of the left buttons, we're going to add a new condition checking for if Bonnie in office is off. Now with the light status flag being off when Bonnie moves in, we'll also need to change the left button visuals as well. Thankfully, since they will never change again, and since the door and lights will both be off when Bonnie moves here, we can just add in an action to change the animation frame of the left buttons to 0. We'll also need to change the animation frame of the office, since if the lights were on, we'd need the office render to reflect that. If the right lights are on when Bonnie moves though, we want those to still be kept on, since the right side will be unaffected by Bonnie moving. So we'll go ahead and add another action to change the office's animation frame, and this one will just be the light status flag of the right button's object multiplied by 2. Since remember, the animation frame of the right lights is equal to 2. There's just one last thing for us to change here, and that's the usage meter, since if the lights get forced off, that will reflect on the usage meter. So we'll just copy one of these actions that changes the usage meter based off of all the door parameters and slap that at the bottom of our actions in line 49. Again, as I mentioned in a prior episode, having this after the light status flag on the left door buttons turns off is important, otherwise the meter won't update properly. Now that we've got all of that set up, we're going to go ahead and make a new line by dragging in the 3 conditions in line 49 onto a new line. All that we change within these conditions is negating this second condition to check for if the left door is closed. So this is going to be the case scenario where we block Bonnie and he goes away. The first action stays the same, Bonnie at door turns off since he's no longer at the door. Everything else though, pretty different. First, we'll make an action that sets Bonnie's progress to 2, which would send him back to the dining area in my case. The rest of the actions will be copied from line 45 since we'll pretty much treat this as Bonnie moving from one room to another. So at the top of the actions, we'll copy the string parser action where it sets its source string to Bonnie's room path alterable string. We'll also copy this force animation frame action that sets Bonnie's animation frame to whichever element is equal to his progress value. So make sure to paste that underneath the action that sets Bonnie's progress value back to 2. Because Bonnie actually goes through line 45 before he moves away from the door, that means his movement timer is already reset and we won't need to paste that in this line here. So now if we run the game finally, we have a fully functional Bonnie that goes away when he moves at the door and it's closed, and where he moves inside the office if the door is open. From here, we're done with programming Bonnie's actual AI, and the last thing that we're going to be adding in this tutorial is the signal loss that happens whenever Bonnie moves either from a room you're looking at or into a room that you're viewing. So to accomplish this, we first need to make another alterable value within Bonnie's object titled last room. Now in our event editor, we're going to go to line 45, the line where Bonnie moves to a room, and above the action where Bonnie's animation frame changes to the new room he's moved to, we're going to create a new action that sets his last room alterable value to his current animation frame. So what this does is it keeps a value of the room that Bonnie was in as he moved. We need this so that we have both Bonnie's current room and previous room to check once he's moved. Now at the bottom of the actions in this line, we're going to make another one that creates a timer event after 0 seconds titled check Bonnie movement. Now in a new line, we're going to make a condition checking for if that timer event of the same name has triggered. Then we'll add another condition checking for if the current frame of our cam rooms object equals Bonnie's animation frame. Now we'll also need to check the room that Bonnie just moved from as well. So to do this, we'll go ahead and add in an or logical condition. If you remember from last episode, this essentially allows us to check for similar conditions whilst activating the exact same actions. So after we add that, we're going to copy and paste these conditions on top of the or logical condition and put those duplicated conditions below it. The only condition we need to change is the last one, checking for if the camera room's animation frame is instead equal to Bonnie's last room alterable value. Now for the action, the only thing that I'm going to do is make the entire camera's layer blacked out. If you want to add text or any other visuals to it, you can do that too. Considering all of the things we've done in this tutorial, it's just a matter of making them appear and disappear at the same time as the actions I'm about to do going from here. So the first action that we'll add is going to be located in the layer object. Now to black out an entire layer, which involves changing something called the RGB coefficient, we'll navigate to Layers, by Name, Effect, and then select RGB coefficient. We don't want to select alpha blending coefficient because that would make the camera's layer invisible and thus make the office be visible whenever the cams are blacked out. Now when we get to the text editor for changing the RGB coefficient, we first need to select the layer name, so that would be cameras for me. And then after are the actual RGB values. Now because RGB takes 3 values in total, one for red, one for green, and one for blue, we need a very specific parameter to achieve what we want. For this, we're going to type in getRGB and then follow that with 2 parentheses. Within these 2 parentheses, we're going to insert 3 values with all 3 of these separated by commas. Now, the 3 RGB values for black is 0, 0, and 0, so those are what our 3 values for this parameter will be. If you've done this right, your expression should look like getRGB, left parentheses, 0, 0, 0, right parentheses. And of course, this can be any color that you'd like. I'm just doing black because for this scenario, it's the most practical. But you can change the RGB coefficient of not just the layers, but also other objects, mostly active objects. So after we implement that, we're then going to add another timer event whose purpose is to refresh the cameras and set their RGB coefficient back to normal. When you want this to happen is up to you, but it really shouldn't be an obnoxiously long amount of time like FNaF 1's 4 seconds, so for me I'll just do it as like 1 second. Then we'll just name this event Refresh Cameras. Afterwards, in a new line, we're going to check for if that Refresh Cameras timer event has just activated. Then for our actions, all we need to do is copy our action that sets the camera's layers RGB to black and paste that into line 52. Now the RGB parameters for the color white, which just makes the colors appear normally, are 255, 255, and 255. So we'll just replace all 3 of these zeros in this expression editor to 255s. Also, don't mind me, I'm just moving this line into the cameras group since I feel like it fits better there. You don't have to do this, especially since the ordering of lines doesn't matter in this case scenario, but yeah. Anyhow, the last thing that we need to do from here, at least what I want to do, is copy the action from one of these camera lines that makes the blip object from last episode and just paste that action into line 52 whenever the cameras black out. Now if we run the game, we can see that anytime Bonnie moves from or to a room we're looking at, the cameras blip and black out for a second. And that will be it for today, methinks. I'm not going to go into the jump scares today because in my opinion, we've done enough today as is, and the setup for the jump scares is a bit of a process. I might wind up doing those as a part of a video of me kind of wrapping up some other smaller things. But in any case, yeah, hope you guys enjoyed this one. Plan for the next video to cover another kind of AI, specifically Foxy's AI. So you guys will get to see the process behind that. Afterwards, a lot of the videos going forward are just going to be on smaller things like the game over and 6 AM screens, custom night, and other dumb stuff. Once we get past the AIs, we'll really be past any of the actual hard stuff with programming the game, and we'll practically be at the home stretch. So yeah, hope to see you guys in the next one. Hope you enjoyed it, and have a great day. Goodbye.